Hey everybody, it's Dr. Rumsey. This is just a quick video to go over visuals, what they are and how they operate. If you are someone that is going on to the 400 level class after this that's in writing, 421, then you'll get a much more thorough discussion of the topic. So the first question we could ask ourselves is simply, what are visuals? Well, according to Wikipedia, thanks Wikipedia, combinations of words and symbols, images, all work together to create a message or a representation of an idea. Okay, so that representation could be of data, it could be concepts or a process, any of those things. What would be included under this would be charts and pictures, diagrams, photographs, graphs of data, that sort of thing. Also tables. So tables aren't typically thought of as visual, but when you think of document design and how regular sentences and paragraphs look on a page, and then you have a table, it stands out differently from the text, and so I count it as a visual in this context. Okay, so another question for you. Are pictures really worth 1,000 words? We've all heard this old adage, right? And most engineers and people in technological fields think immediately, yes. A picture can explain something so much more quickly and easily for readers. There could be pages and pages of text that it would take to describe something, or you could just show them a picture, which is great. Here's an example. This is from R. Tufte, is a scholar that has sort of the definitive information on visuals and how they function. He's a really good read if you're into this sort of thing, so you might want to look at it. So this is just a graphic that manages to compress into it the most information by using both text and images and graph. You can't really see it here, but trust me, if you look this up in his visual display of quantitative information, it is a fascinating read if you enjoy this stuff and nerd out like I do. Okay, let's return to the question though. Are pictures really worth 1,000 words? The answer might also be no. Pictures can distract from your message. Some people could get the wrong 1,000 words from the same graphic. Poor graphics are not easily understood, and the graphic is only as good as the data that you put into it. So here's an example. What you'll notice here is, again, from Tufte. It's a ill-specified or preposterous model or punny data set cannot be rescued by a graphic. So here what you're going to see is A, solar radiation, B, the London Stock Exchange prices, and C are compared by months. Do you think solar radiation and the New York stock prices really have anything to do with one another? No, unless it's another natural disaster, then maybe, but this is just day-to-day in whatever year this was, I guess 1929. Okay, so putting, like, correlation does not mean causation, right? You can find really great examples of bad graphics if you look up correlation versus causation graphics. Funny, like the sale of butter compares exactly with the data set to the number of people who play piano or something like that. It's just ridiculous stuff that's kind of amusing. But the reality is that this graphic does not convey good information. And so is this really worth 1,000 words? Well, yes, but it's not really words that you want them to get. So there's a couple rules for visuals. They need to, quote, tell a simple story. Now, what I mean by that is that you need to make sure that the graphic is comprehensible to your reader. One of the things that technology-focused individuals struggle with is that what is comprehensible to them, what is understandable to them, is not necessarily understandable to outside audiences, and they don't necessarily make that correlation or that understanding between the two. So, for example, you have a circuit diagram, some of you who are in EET. Well, that's great. I happen to know what they are because my husband is an electrical engineering professor, but someone in, say, IT may not necessarily understand what that is, or someone in ME. It's going to know what it is, but they can't read it in the same way you can, okay? Graphics also and visuals need to be clear, concise, and coherent, the 3 C's of technical writing. It needs to be clearly labeled. That means that anytime you put a graph or a visual into a document, you need to have a caption on it, and it needs to also then be ethical. So you need to be responsible with the data. You need to pay attention to audience and purpose, as with any kind of writing. You're going to want to provide a unified message. So that means that you can't just slap down a visual and expect your audience to get, quote, those right 1,000 words. What you might do instead is put in a visual and provide written text that discusses the visual itself. So it can't replace words or explanations. Also, a way to make this really cohesive for your reader is to position the visual very close to the description of what is being displayed. So here's an example. On the left, you're going to see graphics, graphic without text integration. This happens a lot in technical writing. Again, for most of you, you think in pictures. You don't necessarily think in sentences like I do as an English person. And so it very understandably to you put down a circuit diagram and a data table, and that's all you need to understand it. In fact, another EET, for example, is going to look at this and go, oh, I totally understand what that means, right? The rest of us don't have a clue what that means. So then on the right is an example of how you might put figure 1 in there, and then there's text sort of surrounding it. It's just junk text. The lorem ipsum dolor sit is just a text generator, right? So you don't know what it actually says around there, but it is labeled as figure 1, and it's surrounded by text that describes what you want the reader to get out of the visual. So, ethical considerations. Remember that 1929 correlation causation thing I just talked about? Graphics and graphs can be used to hide all kinds of information. They can be used to distort facts or exaggerate trends. A simple bar chart, depending on what the X and Y axis actually demark, can greatly skew data to appear to be much more dramatic or much less dramatic, right? Don't just grab images off the internet. This violates copyright. If you do borrow an image, you need to cite it using IEEE. One thing you could consider doing as you borrow images is looking for Creative Commons licensed images. The law hasn't really caught up with copyright in terms of digital kinds of information. And so Creative Commons is one where someone has put their information, including the graphics, out for people to use freely and within the laws of copyright. So placement considerations. Place a visual as close to the text as possible. So what you might find, though, is that you have a series of 3 graphics that you need to include, and you're writing 1 paragraph about it. Well, you could put the paragraph first and then the 3 images after that. That would be okay. But what happens sometimes is that people want to write the whole thing and then they put all the graphics at the end of the document. And that means that a person has to flip back and forth in the document in order to see the visual and read the text, and it gets kind of cumbersome. So I like things to be more embedded within the text. In our instructions, placement of visuals is really critical to a reader's understanding. If you have step 7 needs to do X, Y, and Z, and that graphic doesn't appear for a long time after, they're going to be completely confused. Here's an example. This one is a good example, right? Click to restore. This person is describing how to use some image software, image editing software. So the step is to click the restore down icon, and then they blow up that top right corner to show exactly what it is they want you to do. So this is a good example of the image going directly with the text so that your reader knows exactly what they're supposed to do. Okay, just a quick overview again. Clear, concise, coherent. They need to be clearly labeled. They need to be ethical, and they need to be integrated with the text so that there's a unified message. You can't just slap down visuals and expect that people are going to understand. You want them to get the correct 1,000 words, and you want them lumped together with the text as closely as possible. All right, that's it. As always, if you have any questions, you can contact me at rumseys@pfw.edu.